Hi everyone, I am Mahendra. You are watching Mahendra tutorial. Today I would like to explain about lens. What are the types of the lens? Let us see first what is a lens. A lens is formed when a transparent material is bounded by two surfaces of which one or both surfaces are spherical. That is a lens is bounded by at least one curved surface. Types of lenses. First one is converging lens, biconvex lens, plano-convex lens, concavo-convex lens. There are three types of converging lenses. First one is biconvex lens, plano-convex lens, concavo-convex lens. These are converging lenses. Second one, diverging lenses. Here also we have three types of diverging lenses: biconcave lens, plano-concave lens, convexo-concave lens. Biconcave lens, plano-concave lens, convexo-concave lens. These are three diverging lenses. See, it is a biconvex lens. Here we have two curved surfaces. This one is the first curved surface. This is the second curved surface. These two are taken from two sphericals or two spheres. The first curved surface is taken from a sphere, and the sphere has center of curvature, that is C1, and also second curved surface is also taken from another sphere. This sphere also has one center of curvature, that is C2. So a lens has two center of curvatures. The line which is passing through center of curvatures is known as principal axis. This is the principal axis. This line is passing through C1 and C2. The distance between the center of curvature and the curved surface is known as radius of curvature. It is indicated with R1. From here to here, the distance is known as radius of curvature. It means center to curved surface. Similarly, the distance between the C2 and curved surface is also known as center radius of curvature. It is indicated with the letter R2. R1, R2 are the radius of curvatures of the lens. The midpoint of this lens is known as optic center. We indicate with letter O. Here, this is the midpoint of the lens is known as optic center. It is a biconvex lens or converging lens. So what are the terms we have learnt? Now we see midpoint of this lens is known as optic center. C1 is center of curvature. C2 is center of curvature. C1, C2 are center of curvatures of lens, and the line which is passing through the center of curvatures and optic center is known as principal axis. F1, F2 are focal point. F1, F2 are focal point or focus of this lens. O is optic center, F1, F2 are focal points or focus. F1 and F2, it means the distance between optic center and focal point is known as focal length. Similarly, the distance between optic center and another focal point F2 is also known as focal length. Small f2. Focal length is indicated with a letter small f, and focal point is indicated with the letter capital F. Here we write capital F1 and capital F2 are focal points. Small f1 and small f2 are focal lengths. The distance between optic center and center of curvature is known as radius of curvature. Here you can see the distance between optic center and center of curvature is known as radius of curvature. It is indicated with a letter R1. Similarly, the distance between optic center and another center of curvature C2 is known as radius of curvature. It is indicated with a letter R2. So R1, R2 are radius of curvatures of the lens. Here it is a biconvex lens, or another name of this lens is converging lens. Now the rays which are parallel to the biconvex lens, see, after refraction all the refractor rays will pass through the focus F1. So the rays which are parallel to the principal axis, this is the principal axis, these are all incident rays. After refraction they will pass through the focus. The symbol of the biconvex lens or converging lens is, here it is. This is the symbol of biconvex lens. Next, biconcave lens or diverging lens. The rays which are parallel to the principal axis, after refraction they diverge. So it means the refractor rays will not intersect at any point, they diverge. So that is why it is known as diverging lens. If we extend the divergent rays, they appear coming from the focus. So the rays which are parallel to the principal axis, when they fall on biconcave lens, they diverge and the refractor rays appears coming from the focus. This is the symbol of biconcave lens or diverging lens. Here we can see the how refraction takes place by biconcave lens. Now, behavior of certain light rays when they are incident on lens. Situation 1. Ray passing along the principal axis. Any ray passing along the principal axis, it is undeviated. Here it is a biconvex lens. The ray which is passing along the principal axis, it does not change its direction, it goes straight. Here also same, the ray which is passing along principal axis, but it is a concave lens. The refractor ray will not deviate, it goes in the straight path. Situation 2. Ray passing through the optic center. Any ray passing through the optic center is also undeviated. It doesn't change its direction. See, this is the ray passing through optic center and it is undeviated. This is situation 2. Ray passing through optic center. Any ray passing through the optic center is also undeviated. Here we are looking the example concave lens. Okay, and here you can see the ray which is passing through the optic center, it is undeviated. Situation 3. Rays traveling parallel to the principal axis. We see the example biconvex lens or converging lens. The rays which are traveling parallel to the principal axis, after refraction they converge at a focal point or focus. Here we can see the how refraction takes place through a biconvex lens. Rays traveling parallel to the principal axis, we see in this diverging lens. After refraction they diverge, and if we extend the diverging rays, they will intersect at one point F. So here the rays which are parallel to the principal axis, after refraction the refracted ray will appear coming from the focus. Now fourth case, ray passing through the focus, biconvex lens or converging lens we see. The rays which are starting from the focus, after refraction the rays will be parallel to the principal axis. Okay, you can see one more time. See the rays passing through the focus, after refraction the refractor rays, these refractor rays are parallel to the principal axis. We are looking now in the biconcave lens or diverging lens. What happens when parallel rays of light fall on lens making some angle with the principal axis? Here we can see these incident rays are making some angle with the principal axis. In this case what happens, how the refraction takes place we will see. All the rays are intersecting at this one point. Here this dotted line is known as focal plane. So when parallel rays making an angle with principal axis fall on lens, the rays converge at a point lying on the focal plane. Focal plane is the plane perpendicular to the principal axis at the focus. So here F0 is the image. Here is the image formed. So when the rays are making some angle with the principal axis, the image is formed on the focal plane. Now we see here also the rays are making some angle with the principal axis. After these diverging rays coming from F0 means focal